BC free response question number 5. The derivative of a function f is given by f prime of x is equal to parentheses x minus 3 times e to the x for x is greater than 0, and f of 1 is equal to 7. So this free response question is fairly simple. All you have to do is find the relative maximum, minimum, to see if it increases or decreases at a certain interval, its concavity, and its integral, and stuff like that. A. The function f has a critical point at x equals 3. At this point, does f has a relative minimum, relative maximum, or neither? Justify your answer. So it already gives you a critical point, and you can make two intervals out of this. So your two intervals would be 0 to 3 and 3 to infinity. Keep in mind that the problem told you that x is greater than 0, so your first interval will be from 0 to 3, not negative infinity to 3. And depending on how the sign of each side changes, it can be relative maximum, relative minimum, or neither. Relative maximum is when f prime of x changes from positive to negative. Relative minimum is when f prime changes from negative to positive, and neither is when f prime of x's sign doesn't change after crossing the critical point. So to test out each side, you can pick an x value that corresponds to each of the intervals. So from 0 to 3 I picked 1, and from 3 to infinity I picked 4. Now you plug these x values into the f of f prime of x, and you get negative 2e, and for 4 you get e to the power of 4. So you see that it changes from negative to positive when it crosses 3. So 3, when x equals 3, it will be a relative minimum. So your justification would be f of x has a relative minimum at x equals 3 because f prime of x changes from negative to positive. So this is the scoring breakdown, so it's 2 points total. Plus 1 for stating that the minimum is at x equals 3, and another point for justifying it. Now let's move on to part B. On what intervals, if any, is the graph of f both decreasing and concave up? Explain your reasoning. First, for f of x to be decreasing, you have to find the interval of where f prime of x is negative. This was already found in part A, and it's from 0 to 3. If you need to rewatch that part, you can rewind to part A. Second, to determine concavity, second derivative is needed. Derive f prime of x, which is given, using the product rule, and I've worked this out on the left side of the screen, and f double prime of x is equal to e to the x times x minus 2. For the f of x to be concave up, find the interval of where f double prime of x is positive. So what you'll do to find this is using the same process you did for part A, but with f double prime. So your first step would be finding the critical number, which is 2, because when you plug in 2, 2 minus 2 is 0, 0 times anything is 0, so that would mean that 2 would be your critical number. Now you do the same process you did in part A. So you have interval from 0 to 2, and another one from 2 to infinity. Plug in the x value, any x value within the interval, find the y value, or your f double prime of x value, find where it's positive, because when it's positive, that interval is concave up. So from 2 to infinity, it's concave up because f double prime of x is positive, and from 0 to 3, it's decreasing because f prime of x is negative. So the question asks you where it's decreasing and concave up. So you'll have to combine both intervals and find where it overlaps, which is from 2 to 3. Here's your answer restated, and here's your scoring guideline. This is out of 3 points total. You get plus 2 for finding f double prime of x, which you have to use product rule for, and you get plus 1 for answering with reasons, such as why this interval is decreasing, why this interval is concave up. C. Find the value of f of 3. To find f of 3, take the information given in the problem, such as the initial condition, f of 1 is equal to 7, and the definite integral of f prime of x from 1 to 3. So this looks like a simple A-B problem where you use the initial conditions and the definite integral to find a point in the graph of f. However, take a look at this integral over here. You can see that you cannot solve this with a simple u substitution. So a concept you learned in BC is required to solve this problem, which is integration by parts. So whenever you have two terms and it's not solvable by using u substitution, most likely it is going to be an integration by parts problem. Now let's solve this out. You pick your u as x minus 3 because it's easy to differentiate, because that'll be just equal to 1, and you set your dv equal to e to the power of x because that's easy to anti-differentiate. So v is equal to e to the power of x. Now here you have your integration by parts formula, so you can use this to integrate this now. So remember that when you're using integration by parts and it's a definite integral, you have to include your bounds, so 1 to 3 and 1 to 3 over here. And by using fundamental theorem of calculus, you can simplify this even further. It's like so, and f of 3 will be equal to 7 plus 3e minus e to the power of 3. Here's the scoring guideline. This is 4 points total. 1 point for using the initial condition of f of 1 is equal to 7, plus 2 points for using integration of parts, and plus 1 point for correct answer. So here are the problems that I recommend that you solve if you had any problems with the FRQ that we just solved. So all of these problems, most of these problems are from the early Transcendentals calculus textbook that we use in class. So I have questions similar to 5A, 5B, and 5C. And I also have a link to CUDA if you need help with integration by parts. So there's a link right there. And I have similar FRQ problems, and I have 4 of them down here. So you can go to any one of these and get extra practice.